Okay, in this video we're going to be covering how to change the design of your fins. I'm going to show you a few options on how to approach this. Before we get started, I want you to once again take a look in Google Classroom, and in our Week 8 folder I have a document called Fin Pattern Examples. I'm going to go ahead and click here. Let me show you this PDF file. Hopefully you've previewed this. And what I'm showing you is 2 pages of proven fin designs. These have been used for decades and decades and very effective. Keep in mind that fins are designed for certain types of rockets, but a lot of good examples of fins that can be used. One I tend to use, it's a pretty reliable, sturdy, easy fin to make, is something like a double swept, this clipped delta. You have kind of this tapered swept currently on your Estes Alpha, and there's a few other options here. Now, I want to zoom in to make sure you understand how to design one of these fins and knowing what edge is the root edge. So whenever you see these arrows that they're pointing, in this case right here, that is the edge of the fin that gets attached to the tube. So this is the root edge. The arrow is pointing towards the front of the fin. This is the edge of the fin that makes direct contact with the air. And this right here is the back of the fin. Okay, so the root is this portion of the fin right here. This is a very important part when you're designing to know what edge goes against the rocket. Okay, so once again, we have 2 pages of proven fin designs, and once again, the beauty of this project is you can get creative and make something original. So currently, we have a fin that is pretty much exactly like the Estes Alpha fin that you manufactured, or I should say sanded and attached to your rocket in level 1. But let's now go over here to the left. Now you need to keep something in mind that this fin is currently attached to the body tube. We have a second body tube. I'm going to go ahead and click on it. That is this portion of the rocket. This is where the altimeter is. Now, if you were to add a different type of fin, you need to first of all go back to body tube here, go back to body tube, and make sure this body tube is selected. If you were to add a different type of fin, it would be attached then to this section, okay? Let me give you an example. Let me click here. If I were to say, oh, I'm just going to use a different fin, meaning I'm going to get rid of this, I'm going to add a new fin set. If I were to select elliptical, you'll actually see the elliptical fins are attaching to the wrong part of the rocket. Okay, in my case, I wanted them to be attached here. Now, to get rid of a fin set, you can simply select it and hit delete. Okay, but let's go back to the fins we originally put in, and I'm just going to double click on those fins. Keep in mind when you're double clicking on these fins, they were called trapezoidal fin set. This is the fins that you use from the tutorials. I'm going to double click here under body tube. And this is the fin we originally put in. So here's what I like to do. I like to keep my eyes on the apogee, and I like to keep my eyes on the stability. Remember, we're looking for a number between 1 and 2, which gives us a stable rocket. It can be slightly above 2 or slightly under 1. So just to show you a little bit of experimentation, we talk about how surface area plays a role in creating more or less drag and or stability. So let's go from a 3-fin rocket. Let's make it a 4-fin. I'm just going to hit the up arrow. Let me go back down to 3. Okay, so we saw 2 things happen. With an extra fin, here's 808. I'm going to add an extra fin. I go to 766. So I basically dropped over 40 feet because I added more drag, a little bit of mass, and in turn, less apogee. You'll also notice I'm becoming more stable. I went from 2.0, I think 8 to 2.52. So adding that additional fin is going to improve stability, but your rocket will not go as high. So let's take this back down to a 3-fin rocket. I'm sorry, 2.04 was the original. And there's a few other things we can do here. We can change the chord. Now the chord, or the root chord, excuse me, is once again the edge that gets attached to the tube. And if you click on this up and down arrow, just to keep something in mind, you can type in something here. You can even slide this because they go in increments of an inch. So you probably don't want to hit the up and down arrows so much as you probably want to either type in a number, and let's just go from what we originally had was something probably around 1 point something. Let's go up to about 3. Let's just experiment here. Remember, I can just highlight this and I can even type in a number like 3. Okay. Now, you'll see that I'm at 790. I've actually become less stable. Interesting. Okay, it's less stable. I did make the root longer. I still have a 3-fin rocket. I'm going to go ahead and hit close. And that's the only thing I'm going to do right now, just to kind of show you how the progression works. Whenever you make a modification, hit close. Now, if you realize, oops, I wish I had not done that, you can actually hit Control Z right now. Watch this, Control Z. It actually brings you back, but you had closed the window first. I'm going to hit Control Y. Let's bring that fin back. So Control Z can still be applied if you made a mistake. I want to go back to your original fin design. Let's go back to flight simulation. Remember, whenever you make changes, we click on the simulation. Let's do a C65 simulation. I hit Run Simulation. Okay, and this is nice. You kind of get a preview of what it thinks you're going to get, but I'm actually going to hit 783. This is kind of a ballpark number here. And I'm also getting a flight time of 63.2 seconds. We're going to hit Plot Export. I'm going to hit Plot again. We talked about this in the previous video. It looks like my recovery and my apogee are almost neck and neck, which is good. Once again, this rocket's now hitting just under 800 feet, made it a larger fin, which in turn brought it down a little bit, and a flight time of just over 62.5 seconds, okay? So we can obviously, once again, go back to rocket design. We can double click on trapezoidal fin set, and we can start manipulating these numbers here. Obviously, I can change the height, okay? But once again, you're probably better off using the slider here to maybe make some of these manipulations. The sweep angle is that back angle, as you can see right there. And the beauty is, as you make these adjustments and then you stop, you can see what's happening. Make the adjustment, stop, and see what happens. See what happens. So this is the beauty of simulation software. You're getting real-time feedback of what is happening as you change the size and shape of your fin. Now, there's a nice little option here. It's called Convert to Freeform. Okay, I'm going to go ahead and click on this Convert to Freeform. So I'm going from just using a lot of sliders to actually manipulating points. Watch this. I'm going to hit Convert to Freeform. Now I want to select this option called Shape. Okay, and once again, I like to keep this fin design rather large so I can see what I'm doing. But at the same time, I want to be able to see this. And I want to be able to see this. This right now is a stable rocket. It's between 1 and 2, what's called cal. 1 cal is 1 body tube diameter between CP and CG. 2 cal would be 2 body diameters. And by the way, we have a body diameter of about 1 inch. So 1 cal is about 1 inch between the CP and CG. 2 cal would be about 2 inches between CP and CG. So you can see I'm just about there, just under a 2-inch gap. Now, here's what this freeform does. This is super cool. I can click and drag, and you can see now the image change. Okay, and I can also, and you have some options here. You got to look at these options. Click, plus, drag, add, and move points. Watch this. I'm just going to click. Okay, I can add points, click, add points, click, add points. So I can start to change the shape of the fin. Okay. Now, I'm going to pause right here, and here's a very important thing to remember about simulation software. Look in this bottom right-hand corner. Jagged edged fin predictions may be inaccurate. Actually, that's a great little warning there, but it goes more than that. Simulation software is simulation software. It's not human. I know for a fact, especially if I was constructing this fin, this would be A, complex, and B, I'm looking at a fin that's probably looks cool, but doesn't perform well. So you have to be careful with appearances. Let's not just make something for the sake of making it look cool. We want it to be effective, okay? So I would stray away from designs like this. And I would also, once again, refer you back to that 2 pages of fins. Now, to get rid of some of these points, I have to hit my Control key. And if you're on a Mac, that's a different key. I don't know off the top of my head. That's the Apple key for the Control key, okay? And I can get rid of these points. So I'm holding down the Control key. Now I'm going to let go. And once again, I can go ahead and start shaping the fin. So Freeform, I have a feeling, is going to be a very popular feature that many students are going to use. Now, a few things to remember. I want you to look at this graph. 0 is here. 3 is here. My root is currently 3 inches long. I would not make this root, let me take this down to about 1.5 inches. I would not make this root probably less than 1.5 inches, because you're going to start to get a fin that may not have much stability, meaning it's going to be maybe moving during flight. Okay, now once again, look at my cowl as I move my fin. You can see the cowl is still stable. Okay, okay, it's starting to become a little bit unstable. So interesting things happen as you make the root edge shorter and longer. Now, once again, this would not be, look at my cowl right now. See, this is telling me that this is obviously extremely unstable because the fin here needs to have the support, and the support you get is where the fin meets the tube. There's got to be some material here to keep it from moving, flexing, bending, turning, twisting while it's in flight. So I would recommend from here, 0 to here, 1.5. I would try to keep this at least 1.5 inches. Now, obviously, be careful on this, the root being much longer. And I usually tell kids, you know, this is a fairly small rocket. I don't see a student having to make a fin longer than 4 inches. So between 1.5 and 4 for the root is probably a good number. This right here, the height, I would say the highest point should be at least 1 inch tall, at least 1 at the highest, meaning everything here is now below 1. You can clearly see these are all below 1. At least something needs to be hitting at least 1 inch. The problem with a fin, for example, like this, is you're not really creating a fin for its intended purpose. A fin is to add stability, and you really don't have much of material here to give the rocket the stability it needs with this fin design. So we need more surface area. We're going back to that term again, surface area. Okay, so the more surface area, the better. Now remember, look at my cowl. This is a very, very unstable fin. So I can, once again, I can start to add some more surface area. Okay, that's much better. I can even bring the root edge in. That's a little bit better. Okay, and you can now see, look, just the beauty about this program is that as I move these points, I'm kind of getting some instant feedback. And I kind of bring this almost back to its original shape, just close to it. Oops, I think I just made an extra point there. Control click, there we go. And there we go. So I'm going to kind of bring this back to its original shape. Now remember, if I really screwed this up, I could hit close. Okay, it's going to show my current fin design. Then I could hit Control Z. I could hit Control Z again. Okay, and look at that. Control Z works in this program. You can go back multiple steps to go back to a step where you want to start off with. Now, I will leave you with one last thing. If you're not interested in a trapezoidal fin set, which can also be converted to Freeform, here's what you need to remember. You need to click on the set you don't want. Now I'm going to right click. Oops, I'm sorry. I'm going to click on the set and hit delete. Now keep in mind, I have a rocket with no fins. Look at my stability, -7. Okay, to add a new fin set, click on this body tube, please. Okay, and there might be students that want to use elliptical. Okay, and you can even start off Freeform. Let's just say I hit elliptical. So once again, the elliptical fins are going on the correct body tube. Okay, so once again, here also you can start manipulating from a 3 fin to a 4 fin. Remember, we're making 3 or 4 fins. Okay, you can see the apogee here changes from a 3 to a 4 fin rocket. We can change the root chord, you can change the height, and once again, you can go back to convert to Freeform. You can go to shape. Careful with elliptical, because as you start to move some of these points, okay, it could get a little complicated. So elliptical might be something a little bit more more involved to change the shape, but there are obviously some features like scale fin, where you can actually scale this fin down. Let's see if I can do this here. Okay, let's go scale it to a smaller number. I'm going to hit scale. Okay, it actually reduced it down from to 70% of the original size. Okay, so it's got some cool features here. Okay, and things that I want you to experiment. All right, so I'm going to hit close. And once again, every time you make an adjustment, okay, you have a preview here. You have a preview here, but really you need to go back to flight simulation. Let's use a B64 this time. You're going to hit run simulation. You see the little green circle? That means we have a fresh run of an installation. Apply to export if you want to, or simply read the data. This is hitting 358 feet. It has a flight time of 30. Okay, so we can see a substantial difference between the B and let's run the C engine. Run simulation and a C. Okay, definitely a difference because you're going higher, which means it's going to take longer for the rocket then to come down. Okay, so we're going to stop this video. We've shown you how to manipulate either a freeform fin, taking the original trapezoidal fin and or converting it to freeform and or adding an elliptical. But once again, folks, make sure you select the right body tube when you're adding your fins. And remember, Control Z can be used if you make any mistakes and need to go back. Okay, we're going to go ahead and jump into the next video.